All right, guys, let's get started. 6 o'clock. So today we are going to go over some of the environment and tools that we will be using for the course. So that basically means Anaconda. So hopefully you guys already installed this on your computers, right? So I'm going to demo just how to create an environment. And then we're going to start playing with Numpy, basically. We'll do I'll point out some of the exercises. I'll go over, the basic ideas, okay? And then basically next week, probably we'll start getting into machine learning algorithms, okay? So currently last week we just looked at how to take a word problem and convert it into a machine learning problem. And this week I'm introducing, the tools, plus we're making a review of Numpy and Numpy operations. Okay, any questions before I begin? No questions? I did get Scholar, the Scholar GPU. He's gonna help us out quite a bit. So Henry, and I haven't created your accounts yet. I'll try to do that tonight or tomorrow. And then once I create the accounts, you'll start seeing something that you have to log in. And maybe by Thursday, I will be able to show you guys how to get into the GPU Scholar. Remember, that's a queuing system. So it's basically you request a GPU and then it becomes available really quickly, or it takes a while, right? So it really will be mainly for homework assignments, not for like in class. It'll be hard for all of us to get a GPU and that have it to be guaranteed. But for your homework assignments, I think you should be able to do it. So at the beginning of the homework assignments, you can do on your laptop, but eventually, once we hit like Sci-Fi 10 or something like that, you will need a GPU. So yeah. All right, but anyway, we'll talk about that later. So I still need to work on that. But today we're just going over Anaconda. Now, what we're doing with Jupyter and everything, that's going to work on Scholar, the Scholar GPU. They also have a Jupyter lab and Jupyter notebooks there. All right, so today, basically, so let's go to I think I started the recording here already. Yeah, so it's recording. Let's hit on the share screen. Okay. So we're in the table of contents. We've completed this first module. Now we're going over the second one, which is basically this. I will change these problems. Okay, so these are probably from last semester. So I'll wait until I create a few new problems for your homework. Okay, there will be between 3 and 5 problems for you to solve. Now this is basically a list of a lot of examples of using NumPy that I have, okay? I'll do some of these today, but I'm not gonna have time to do all of them. So this is what I was talking about when I said that to develop muscle memory, right? So basically what I want you guys to do is to go through all these problems. Now the problem and solution is here. And I just want you to, do them, run them, type them up, take your time as an exercise. It'll pay off later, okay? Because, you want to see how, okay, if I create an array in NumPy, how does that work? And then if I start processing it, how does that work? All right, so there's a lot. I provided a lot of examples here of the common things. The hardest thing in here is something called broadcasting. It's an essential concept in when dealing with matrices and vectors. In NumPy and all the environments have it, TensorFlow and PyTorch. So don't worry about broadcasting just yet, okay? That's a tough thing to understand. So it'll take time. But I have an example in there. You can take a look at it, of course, if you want to. It's like definitions of how it works to really understand it. And it can be tricky. But the other thing should be pretty straightforward. We're going to go over them today. So today I'll create, I'm assuming you guys have installed Anaconda already, right? And so I will just show you how to create your environment. we're going to create a folder, then the virtual environment. So if you took 372, you probably remember this stuff, how to create environments, or you've used Docker or something like that. You have a sense of creating these environments for containers and things like that, right? But I'll go over that today. And we'll install some of the libraries. So we should be able to install some of the libraries, Numpy, and then I'll do some examples of the basic things, creating a Numpy array, a vector, a matrix, and then doing things like indexing and slicing. Slicing is a concept that you need to just understand really well. You will be using it a lot, okay? And you'll be you've probably done this already in 265, so this is more of a review. But as I said, I do provide this list of problems. Please go over them. It's not homework. I'm not going to ask you to submit these, right? So I don't know if you do them or not, but I suggest that you do them, okay? First of all, because you won't be able to solve the problems, I think, if you don't do the examples, right? So go through them. So I provided the link here. So it's in the matrices, vectors, and Numpy. So this is the idea, is to get everyone caught up. This is just, like I said, 3 or 5 problems from last semester. I'll change this. I haven't created the homework yet. I'll do that on Thursday. I did create the word problems for this module. All right, so I'm gonna click on this, okay? And that should take you to my GitHub where I have all these problems, basically, right? You can see there's a lot of them, but all semester, we're going to be doing operations like these, okay? These operations provide a lot of efficiency. This is how you do machine learning, okay? If you want to, you want to use GPUs to speed up your training, etc., you got to do operations different. You have to think of this concept of doing things in parallel, right? And GPUs do this. They move things in parallel very efficiently. So we want to be able to do this. So for instance, I'll give you this example. We have, 2 times 2 is 4, right? 3 times 3 is 9. 3 times 3 is 9. And then 1 times 5 is 5, right? Those 3 operations. So a good analogy of this is on the CPU, I would do 2 times 2 is 4, 1 second. I'm exaggerating here. Then 3 times 3 is 9, another second, that's 2 seconds. 1 times 5, 5, 3 seconds, right? Sequential. GPU would take 2 times 2, 3 times 3, and 1 times 5, and all at the same time in parallel. Again, exaggerated, but 1 second. So where one took 3 seconds, the other one took 1 second. So you can imagine how that's going to speed up the machine learning training, okay? Machine learning is not just, especially today, more, now, maybe 15 years ago, it was more like just the algorithms, the math, etc. But today, machine learning is actually the math, the algorithms, and also like the computers. Now, you guys are, you're in the right field, right? IT and everything. You love working with computers and cloud stuff and things like that. That's a huge component of it, right? And it's actually the barrier of some people that might be very good at the algorithms, but just can't get the GPU and everything to work, and the hardware. I'll give you like a little. Just the other day, I was running my GPU, and it was very slow, and I had to like hack it until I figured out the driver was too old. So I had to update the driver, and then immediately it sped up, right? So this is still an area where you got to get in there and work on your computer, okay? Anyway, so a lot of it, my point is, a lot of it is dependent on the architecture that we're using, the hardware, the underlying hardware is a big problem. All right, so these operations are essential to speed things up, right? To do those 3 multiplications at once, we just have to learn how to think about that, how to think differently about coding, right? So for instance, one thing I'll say is that whenever I'll give you a problem, and your first intuition will be to write 2 for loops. You'll be like for this and this, and for I in this, and then for J in this, and you're gonna do that, right? And you're gonna find out that you are not gonna be doing operations like that anymore. Okay? We don't want to. Sometimes we'll use for loops, but not. Yeah. No.
Is it because Python is very slow?
Well, that's a good point. Python is you can think of Python as an interface to C. So the libraries, underlying libraries are actually C, right? But yes, Python is slow because it's, it can, first of all, it can take advantage of compiled libraries in C. And also it's not meant to be like C++, right? But it's also easier. But I would say it's not because of Python, because you could do that in Java or other languages as well. It's because of GPUs. That operation of 4 and 4 is like iterating over a matrix, right? And you're looking for things. Whereas you want to think of it, how would I do this in a GPU? How would I do? So my point is also that any operation that you do with those two for loops sometimes has an equivalent matrix multiplication that achieves the same thing. You see what I'm saying? Like you can sequentially create a set of for loops that search, organize, find a thing. Or you can find the equivalent multiplication of matrices that also achieves the same result. You see that? Yeah. So that's actually a good way of putting it. So it's funny how I always find they found a way with various multiplications of achieving something that you could also do with a whole bunch of for loops. Okay. So now we're not going to be doing things as complicated as that, but you will see that you will need to, whenever we're looking for values in matrices, I'm not going to ask you to like iterate through every element in the row, and because that's sequential, right? And we need to think in terms of Numpy, right? Matrix multiplications. All right, so this will become more obvious as we start going through the algorithms. Today, I'm just going to introduce some basic operations. Does that make sense, guys? Okay. All right, so as I said, this is kind of really important. All right, so I've shown you where the link is, right? So as I said, I'm not going to give you a homework of this, but please go through all these problems. Today, I will start and just kind of discuss as many as I can, and you guys can finish up the rest on your own, okay? Questions? All right, so let's get started. So the first thing we need is we haven't looked at the environment, right? And the environment is going to be Anaconda. So we're going to go ahead. I think I haven't created the folder yet. So let me do this. I'm going to open up this and I'm going to go to all apps. So this assumes you've already installed Anaconda. Then I'll click on this. And there's several ways of doing this. I like to do it this way. I'm just used to it. So I open the Anaconda prompt, which should be installed on your computer once you've installed Anaconda. Okay. Now this is Windows. So we need to remind ourselves of how to navigate here, right? So dir is the directory listing. So I will go to the desktop. And let me move this up a little. All right, so then I'm going to do dir here. I'm going to create a folder, ITS 365, 2024. I think I created that. Yep, there it is. All right, so I'm going to navigate into it. So I'm going to do ITS 365, 2024. Okay, I just, this is where all my scripts are going to live. Most of my scripts are probably going to be Jupyter notebooks. Yeah. So then I am here. Okay, there's no files, right? So now you've installed Anaconda, right? That's the assumption. So on your Anaconda prompt, you have this called base, right? You should all have this. You're there. All right, so now we begin to use Anaconda is the way to go always, right? So what we need now is to create our environment. So I'm going to give you a few commands. So conda environment list is what I like to type to see the environments that I have here, the virtual environments. So I have a few. Okay, so I don't have one for this class here, so I'm going to create one, and you guys can do the exact same thing, right? So the command for that should be conda create -- name. Then by convention, I like to put the version of Python that I'm going to use on the environment. So in this case, I'm going to use Python 3.7. A lot of the code libraries run on that. If we encounter something where we need Python 3.8, then we create an environment, Python 3.8 or 3.9. And if you have a program that runs on Python 3.6, you create that. And that's the beauty of this, that you don't have to now, change a version of your Python or other module for the whole operating system. You just do it on a per environment basis, right? That's the beauty of these things. So I'm going to say Python Py37, and then I'm going to call this ITS 365, just so that I know that this is going to be my environment for the course. Then here I'm going to say Python equal 3.7. So that just means that's the library or the version of Python that I'm installing. Make sense? So go ahead and hit enter. And it's gonna, so this is how this works. It starts to upgrade the software and it starts to create your environment with Python. And then once we have this, we can go ahead and start to install other libraries. Okay. Now, one thing I don't like to mix PyTorch and TensorFlow. So if for some reason we were doing something in TensorFlow, hit yes here. Then create one for TensorFlow. And then if you're doing one for PyTorch, create something for PyTorch. Okay. But right now I'll probably just do Torch and Jupyter as installs. And then I believe when you do Torch, it also installs Numpy. Okay. So now you can see it finish, right? And it's telling you how to activate the environment. So it just says conda activate and the name of the environment. You can also do conda environment list, and it's going to list out all the environments that you have in this system. So we should now, here it is, Py37 ITS 365. So that's the one we just created. We are still in base. So now we want to get into the environment that we just created. Py37 ITS 365. All right, notice that when I hit enter now, base changes and it says Py37 ITS 365. That means that I am now in that environment, okay? And this is where you're gonna do all your development. Now, this is independent of the files and the file system. So the folder, that's a separate thing. They're not tied together. The folder just holds your files, and the environment is the one that's tied to the libraries and the versions that you install. Got it? All right, so the next thing I'm going to install is Torch. So here we have two ways of installing. You can install through Conda or you can install through pip. Never mix them. I don't mix them because sometimes you may install a dependency with one and that doesn't work with the other one. So be consistent. In general, I prefer pip. All right, so I'm going to do pip install and I'm going to do Torch here, which is it's PyTorch basically, okay? This is the deep learning library that can allow us to create anything all the way to like a transformer or whatever we want to do. Make sense? So go ahead and hit that one, and it's gonna install those libraries. You can see it's going there for this particular environment. So it takes a while. Yes.
PyTorch is Facebook's, TensorFlow is Google, right?
TensorFlow was started by Google, and it's probably still Google's. PyTorch was started by some community, then it was taken by Meta and Facebook, and I believe it is now its own foundation. But still, yeah, Meta is dominant there. Yep, you're right. All right, so it finished. That's good. Now, the last thing we're going to install here on the command line will be Jupyter, because that's really where we're going to try to do all of our work. Okay, so for this, I'm going to do again pip install, and then I'm going to type Jupyter. This is the famous Jupyter notebooks. Okay, so very nice for displaying things and running our code. And that's, it's quick, right? 10, 15 minutes and you've got an environment going. So as long as you have Anaconda in your system, you can create as many environments as you want. If you want to get rid of one, you just remove it and that's it. Right, so mine takes a while on this computer. So while this is going on, so basically Python has its own objects and data structures like lists, right? But processing lists and arrays in Python can be very slow because as Henry said, you're kind of using Python itself. Numpy is a library, right? And the things in that library are compiled in C. So the underlying programs that are running are these C binaries. And so while you bring in NumPy into your Jupyter, let's say, you give the data in Python, you can imagine that data actually ends up running in C code, all right? But we don't have to code it at that level. That's the wonderful thing of this. So it runs, we get the speed of C++, but we just write code in Python instead of having to write it in C. Nothing against that. I mean, it's great, but it's harder, of course. All right, so now I've installed a Jupyter notebook, right? So now I want to start Jupyter. So you do Jupyter notebook. And this should open up on the browser, basically. Now we have what is called the Jupyter notebook. You can see it opens this terminal. Don't close this or kill it because you're going to be killing the Jupyter notebook interface. It may have opened it back here, I think. Yeah, here it is. So you should look for something that looks like this in your in the browser. So now, basically, it's displaying all the files in that folder that we just created. So that's the key thing. You want to navigate into that folder, right, where you want your files to live. Okay, so when we create a file here, it's going to be saved in that folder. So now I'm going to go ahead. So you can see here, I have nothing. And I'm going to hit new. And I'm going to say Python 3. And that opens a new tab, which is going to be the actual Jupyter notebook that we're going to be using. This is where we're going to write our code. But this is really nice because, as I said, you should probably create your own GitHub at this point. If you haven't done so already, have a GitHub, load your files there. You can always read things, and it's basically like a notebook. Like you can write equations here, you can put images, you could put, whatever you want in here. Okay. So a couple of things. These are the cells, so I'm gonna add more cells. All right, just so I have a few cells in here. Then I'm gonna change the name. So here and rename, and I'm gonna say this is gonna be NumPy examples. I'm gonna say 2024 for my case. And I'm gonna hit rename. You can give it any name that you want. Usually I like to put a comment here, and I'll just say like NumPy examples. And then I want this cell by default is a code cell, which means it'll run Python code, but you can make it into like a notes cell, right? So you go to cell here, click cell type, click markdown, and it is now a cell that does not run code. It's just basically text. So now I can hit run and you can see it becomes kind of more presentable. You can add here all your notes and everything that you want. All right. So now we are ready to go. Let's do import numpy as np, right? Just to see that we have it, right? So I've added the library. I'm going to call it np, and I can, wherever I am, let's say I'm in this cell, then I'm going to hit run, and it's going to run that code, right? So over here, there's this circle. It'll become solid whenever it's running, okay? And if there's any problem, it's going to give us an error. So there will be some error to deal with. So hit save, run. Okay, so it's saying no module named numpy. So it's actually not installed, right? So then you might want to go back to the command line where we were, or you can also install programs here. So usually I like to do basically the pipeline I showed you. I install like Torch and then the Jupyter Notebook, but the rest I install here. So let me add a cell in between. And then the trick is you add an exclamation mark, and then pip install numpy, right? For instance, which is the library that we need. And we can do this for every single library that we have. So now I'm going to hit save. I'm going to hit run. Give it a minute. We should get some output possibly. Oh, there it is. So, and it said it finished installing NumPy, and that's it. So now NumPy is installed. So I can test that obviously by running the cell where I try to import NumPy. I'm going to go ahead and do that. And as you can see, it's thinking. So it's doing the solid circle. It finished, no error, and it moved to the next cell. We're good. Everyone with me? That's it. That's kind of what you'll do for every library that you need to import, so that's it. So now we are ready. The other thing I guess I will install is matplotlib. We'll be using that. Now, another thing is I don't want, by accident, you may click on this cell again, and then you're like installing things. You only need to do it once. So I suggest you just add a comment in front of it so that, first of all, you want this output to go away. You don't need it anymore. Okay? But this reminds you that that's a library that you need. And if you put this on your GitHub and someone else finds it, they know what programs they need to install. Okay, so it's very handy. All right, so I'm going to add matplotlib, which is another important one. So matplotlib dot pyplot as PLT. So actually, this is so important. We have a class for this, which is the data visualization class that Professor Gurjin teaches. So he would cover these things of matplotlib, etc., in more detail than I will do here, right? That class is all about visualization of data. All right, so this is matplotlib.pyplot as PLT. This is just basically so that every time I need it, I don't have to use this, right? I rename things to something shorter, and this is like very common approach, okay? Standard, if you will. All right, so I'm going to hit run. Again, the library is not installed. So then we do the same thing. Pip install matplotlib. Go ahead and hit run. It's thinking there. All right, so you always want to check the output and you want to see successfully installed basically, but there are no errors. Okay, so it's done now. So I'm going to comment it out, get rid of that output by running it again. And now I'm going to run this one, let it finish. So it's solid. Okay, and that's it. So that basically means that your code is working. Any questions? That's the environment. That's it. that easy. Okay. This runs very well on Windows, Linux, Mac, doesn't matter. Does not care. Right. So it didn't used to be this way. 2-3 years ago, this was more painful, but now it's very smooth. All right, so let's go ahead now. Now we are ready to go through the exercises. As I said, my best recommendation with this, go through all of them, type them up by hand, keep them as a cheat sheet, if you will, on your GitHub, come back to them. Because, as we start getting into the algorithms, the first algorithm we'll get into is Weka, which we'll probably start next week. We'll start using this stuff right away. We'll use list comprehensions, we'll use slicing, we will use lots of things. All right, so here I've broken down a lot of those operations of the future into just like the individual components, but I haven't done it with all, right? So it's just a few. But anyway, so this is what we're gonna be doing. Now, Numpy, TensorFlow, and PyTorch basically all copy each other, okay? So they all, it's like this thing, like Numpy honestly was ahead in developing this really nice library. And then TensorFlow and PyTorch just, they can do things that Numpy can't do, at least couldn't. I mean, they've been updating it, but it does something, right? There's an operation that it does, TensorFlow and PyTorch. And so they could do that, but, otherwise they were not so great at managing or manipulating matrices and vectors. So over time, they started to look at Numpy, which is really good at it. And so it's like they've been copying Numpy. And so that's one great thing about this is that sometimes you do something in Numpy and it's very similar. In TensorFlow, it's very similar in PyTorch, okay? Sometimes the name changes a little bit, but very similar, okay? Now, I'll be talking about matrices and vectors, and just keep in mind that there's a general term for that, and that is tensor, all right? So tensor is the actual name that could mean a matrix, it could mean a vector, it could be a 2-dimensional or 3-dimensional or 4-dimensional, a cube, a hypercube, whatever it is, all of those things are basically tensors. So that's why TensorFlow is called TensorFlow. So it's just a thing that manipulates these objects. So it's very important. All right, so let's do our first example, okay? So I'm gonna create an array, okay? So I'm gonna go back to here. That's the first example, right? The first problem. So in Python, we have lists, like L1 would be a list. Remember, it's square brackets. And then we have a list of numbers like 4, 5, 2, 6, 8. So that's a list in Python, okay? Usually, as I said, we don't want to operate in Python list. Instead, we convert everything into a NumPy array, what is called a NumPy array. So here's an example of doing something like that. I'm going to, create a new variable A, and I'm going to invoke NP. Remember, NP means that I'm actually invoking NumPy. So I'm going to say NP dot array. Okay. And then this array will take basically that list, which in this case is L1. You see that? So now, if I'm going to do that actually in the next cell. I want to show you something. All right, so we have an object L1 and we have an object A. So I'm going to run L1 and you can see that is basically a native Python list. Okay, but now I'm going to convert it into a NumPy array and you can see it looks different, right? It's a different data structure. The values may be the same, but the processing of these data structures in memory would not be the same. Okay. So it's really important. All right. So this is our objective, to convert things into NumPy arrays. And in the future, just like we converted it into a NumPy array, we'll have to convert things into a torch tensor or a TensorFlow tensor. Okay. So the data structures are very important. And each one has their own. But there's nice handy ways that we can go from a torch tensor to a NumPy array and from a NumPy array to a torch tensor. You can't, when you use deep learning libraries like PyTorch, you cannot combine. Like you can't in the graph put a whole bunch of torch tensors with a whole bunch of NumPy arrays. That's not going to work. Everything needs to be a torch tensor. Okay, so you'll see that later. But anyway, that's your first example of NumPy, right? So there you go. You did one. Now let's create another. So now I'm going to do a np.array. Oops. Array. And I'm going to show you these things have a tendency to be more verbose, which means there's a lot of flags and parameters and words, and you just have to get used to it, okay? So for instance, here I'm going to create a NumPy array with the following values, 3, 2, 5. And then I'm going to add a comma here. And now I'm going to specify that I want a data type. So you can actually specify the data type. And in this case, it's going to be float 32. Okay. Data types, even though maybe in Python you've never seen the use of data types, in this realm, data types become an important thing again. Okay. And that's because, you know, you're running underlying C libraries. You want to be very efficient, right? So you specify things like float 32, the specific size of your values. Okay. Got it? All right, good. So we create this NumPy array here, and now we can go ahead. You can also do print, but you probably noticed that in the Jupyter Notebook, you don't actually have to do a print if you only have one value. It just shows like the last one. Okay, so here I'm going to do run. You can see that you'll get used to eventually that this is a NumPy array. It's got its own, no commas, for instance, in there. You can see that it's got these dots at the end. It's telling you that it's a float, basically. Okay? All right. Now let's create a matrix, basically. So I'm going to create, first I'm going to create a matrix from 3 lists, but the 3 lists are not going to have matching dimensions. So we're going to see what happens. So I'm going to create list of lists. Okay, list of lists is going to be equal. Now to do this, we use square brackets, right? And then within this, we're going to add the 3 rows. Okay, like that. All right, so basically we want it to be a matrix, a 3 by 3, right? So 3 rows and 3 columns. So we would want it to have, you know, the correct sizing. But here, NumPy needs specific dimensions to be able to create the matrices for us. All right, so let's take a look. So I'm going to do 1, 1, 2, 3, and then 4, 4, 5. But notice that in this one, I'm just going to add 2 values, 6, 2. Okay. So I'm going to try the NumPy array function. So I'm going to do b equal np.array, right? And this NumPy array is going to take list of lists. Okay. So I'm going to print b. See, it doesn't quite like it, right? It's giving you it doesn't like this type of initialization of this matrix. All right, so instead, let's give it one that has equal dimensions. So I'm just going to copy this exact same code. Now, this doesn't mean that all matrices in NumPy need to be square matrices. It just means that this initialization doesn't quite work. So we have to find other ways of doing it. Okay. So now here I'm going to change it by adding an extra value. So I'm going to add 11, be consistent with the notes, and run this one. And as you can see it like that, so it immediately does it for you. This is now a proper matrix. It is 3 by 3. Now, both TensorFlow Torch and Numpy have this functionality, the shape function. This is like, I can't tell you how much I use this. It's really one of the key things, because at the end of the day, you always want to know the dimensions of everything, right? Remember how I emphasize what x times n by m, right? So what is the number of rows? What is the number of columns? All that stuff is really important. Knowing the shapes is really important. So here I'm going to do b dot shape, okay? And you can see it tells me that it is a 3 by 3 matrix, okay? This is, as I said, really important as we start getting into the algorithm, okay? Any questions so far? Pretty easy, right? So you're just learning these operations, and these are things that we'll be using. Now, there are other ways of initializing matrices. So we have things like the zeros function or the ones function. So let's do that. Okay. So I'm going to do b equal np dot zeros. And I'm going to say that I want basically a vector of all zeros of size 10. So this is a vector, right? It's a one-dimensional row or column. And then I'm going to say even the data type that I want. So I'm going to say data type equal int. Okay. All right. And then I'm going to print it. And there it is. So you're able to initialize. This is useful sometimes, like if you want just a grid of values. You can print the shape. So b dot shape. So you want to do b dot shape here. Okay, and it tells you that it is 10. Any questions? All right, so let's do another one. We're gonna do all ones. Let's do b equal np dot ones. Let's do 4, 6. So that's going to be 4 rows and 6 columns. We're going to specify the data type, which is going to be float in this case. Okay. And then we're going to print b. And you can see it creates a matrix of 4 rows, 6 columns of all ones with data type float. Okay. Pretty easy. You can create one with any number that you want. So we can try b np dot full. We're going to specify the dimensions of it, 3, 3. And we want it to be value 42. Print b. And you can see it is a 3 by 3 of a value 42. Okay. Now, other things that we can do is sometimes we might want a range of value, right? So like a vector with a range starting at one value and ending at another value. So I'm going to do that with a range. B equals np dot a range. And then we're going to say that it's going to start at 1 and it's going to end at 30 with a step size of 3. Okay, so it's going to generate basically this list of values for us. So let's go ahead and hit B. And there you can see, starts at 1, then plus 3 is 4, then 7, and so on, until it gets to 28. And that's the A range with step size of 3. Okay. We have another similar function, linspace. So we can do b equal np dot linspace from 0 to 1. And here you say that you want 20 values. Okay. So it's going to figure out. So this one works different, right? Now you can always, whenever you have a question about these things, go on Google and just look up np.linspace, right? It'll take you to the documentation where it's going to describe what the function does, what are the parameters, etc. There's a lot of these functions, so that's the best approach for that. Okay. All right, so go ahead and hit run. Oh, I forgot to print it. And there you go. So it creates from 0 to 1, and it creates 20 values in a linear space, basically. So you can see it's incremented. Any questions? All right. Now, obviously, random is something that we would usually do. All these have patterns. And really, when we're initializing things that a neural network is going to learn, you know, like the weights, it basically would be random initialization. So we have random functions. So let's do same thing. B equals np dot random dot random four comma 4. Okay. And we're going to do print. Okay, so this is a 4x4 with random values. So you can see that there. They're random basically. This is 0.82, that's 0.99, this is 0.19, 0.37, random. Questions? Yeah, go ahead.
For random, can you specify the data type, like int or something?
You want int? You could multiply this, I think, by a specific number and round it to convert them into integers. What I would do, type equal int.
Yeah.
This is, yeah, I don't know if this will work for this function, but intuitively, you know, this is what you would assume. So I didn't like it. So I got unexpected arguments. There is no D type for this
Oh, wait,
function.
do you need, like you did with the float 32, with quotes around the float 32?
I can try that. Did I put quotes on it? Okay, D type.
It's like unexpected arguments to the brain. It's not like.
Yeah, it doesn't like it, but it's because you can multiply this times on whatever factor you want and then round it and get the numbers. So I think they just don't see the point of having that when you can do it yourself. So yeah, it doesn't have it as an element. Okay. So there's our random. Okay. So again, I may skip some of these, so I'll let you guys go through them. But you should go through all these examples. I want to touch on some specific ones today. And there's one here like the identity matrix. I mean, we're not really going to be using that much. But yeah.
Identity matrix.
Sorry? Identity matrix is where the diagonals is all ones for a certain type of multiplications. But like I said, that's more of a like getting into very specific things. So it's in here. Go through it. All right. So I'm just saying I'm skipping a few of these because I definitely want to touch on certain things. Okay. And the identity matrix is not something that we use in this, but it is used for other things.
I'm assuming identity matrix multiplies everything by.
It's when you want to do certain operations, you use the identity matrix. It's basically this one here. this one, where the diagonal has all ones. So it's for that type of operation. When you want to extract some things out of another matrix, sometimes you apply this. But anyway, we won't be using this that much, basically. All right, so let's move on. Okay, so we've created random matrices. Yep. So there's several examples in there of creating multiple. Yeah, go ahead.
We have to do random twice or random.
One is the library. Oh, and then there's several methods within it. So there's Numpy, and then Numpy has a special like random module, but that random module may have several things in there. There may be a rand int, for instance. I don't remember the exact, but that's a good example. There may be this one, a rand int, and another. So there's several functions. Okay. All right. So like I said, in the notes, there's several initializations of several random matrices of different sizes. I leave that for you guys. And I want to move on to one of the important topics, which is indexing. Okay, so that's, we're going to look at indexing first, and then we're going to look at slicing. These are things that you guys will be using a lot. Okay. All right, so let's look. I'll add a heading for this one, indexing. So type markdown. Right. Okay. Gonna add a few more cells in here. So in this one, what is indexing? Indexing is just basically extracting values from your NumPy array. Okay. So I'm going to create a NumPy array, A. So I'm going to do np.array. And then I'm going to add a list in here. I'm going to say 1, 3, 2, 5. And then dtype float 32. I'm going to use this print. Okay. And let's print it. Okay, so now indexing just means extracting the values from the array, right? So we want to extract the first one. So I'm going to do print first, comma. So that would be A, and then the index. What's the index here for the first one? 0. Starts at 0. Oh, that's right. So then I do that, and there it is. First is 1, which is that. Okay. Now let's do the last. Print last, comma, A index. So what's the last? Why -1? Well, it's because it starts from the other end. That's all it is. So if I do -1 here, right? I get 5. That's the last one. Okay. What if I want this one? How do I get that? I can get that by saying, so I'm going to go here. I'm just going to print. I'm not going to do the wording anymore. So just A this, right? So there's two ways of getting this value. I could either do start from this side, 0, 1, 2, correct? Yeah. So I do 2 to get this. I want the 2, right? So I get the 2. Or I want this one, but from the other side. Okay. So then I'm going to do A, and then what would you do here? Yeah. -2.
Is there a reason to walk down the way like that?
Do you see that? So I was able to get this. Oh yeah, there's a reason. Oh yeah. I'll give you an example right now. ChatGPT. ChatGPT creates a sequence of words. But the word that you care about is the last one, right? That's the word that it predicts. Every time it's got like a sequence, right? Like you guys say, the car is going really fast. If I just say going, you don't really know what I mean, right? You need the full context. The car is going really fast or slow, right? So a large language model needs not just going, but the car is going really. So it needs all of those things. And then it only wants the last one, -1. So you can get the -1 with the -1. I mean, it's going to be a NumPy vector of IDs, and you just get the last. Yeah, go ahead.
Would -5 also -5, or does that not work?
If it's out of range, it's not going to work, I think. -5 is outside of this range, right?
So
So
it's -1, but
-1, -2, -3, -4. You can always try. Oh, you think it wraps around maybe?
yeah,
I don't believe so. I don't believe it does that. I mean, we can try it, -5. That's the great thing about this, right? Is that you can always try it. It's out of bounds.
I know, but
It's a convention, Henry. It's just a convention. It's how it is. It intuitively made sense to someone to do it that way. They all do it like this. All languages is implemented this way. At least it's consistent. What if it wasn't consistent? That would be even worse. You wanted it to be -0, right? Or something like that. That's why you're stuck in this. But that doesn't. Yeah, it's not a real. So mathematically speaking, people couldn't accept that. So -1.
It's not like, I guess.
What is bothering you?
I guess what I was talking about is like, would it just be length -1, then length -2, length -3?
So you think I mean, it's it was made this way, you know. It might be the -1 may be length -1. I mean, it might be something that it's in NumPy being done exactly as you think. All right, so anyway, this is indexing. We are just getting the values, okay? So that's kind of the idea. And I've shown you all the exercises, I think. Let's try a matrix, right? So we have a matrix. So now I'm going to do still indexing. I'm going to create A equal NP dot array. And then I'm going to add my matrix here. So another way of creating a matrix is to do something like this. So I'm going to do there, right? So it auto completes for you. And then now I'm going to do 1, 2, 3, 4. Then here I'm going to add a comma, move this one down. I like to align them a little bit. And then 5, 6, 7, 8, comma. And then the last one, 9, 10, 11, 12. Oh yeah, it's because of that. All right, so there you go. You don't have to do that, but it's better code like this. It's cleaner. All right, so we are initializing our matrix here. So there we go. We have a matrix. Now we're going to index. So let's print it first. So I'm going to do a print. There's my matrix. So proper NumPy matrix. How do we get the first element, that number 1? Okay, so we would do A. Okay, and then for indexing, 0, 0. Got it? So that should give us 1. There we go. We got the 1. All right, what else do we want? Let's now give me the last element. The last element should be 12, right? So who wants to tackle that one? What's the last one? -1, -1? Maybe it is. Ah. Yeah, it works though. All right, so anyway, yeah, sometimes things will frustrate you a little bit with these languages, or these at the end of the day, they're just people implementing these functions, right? So it's however they thought of things. All right. So yeah, so that's indexing, and that was fun. I think a more fun and certainly more powerful thing that we need to master is something called slicing. All right. Slicing is like, imagine a cake and you have 12 guests, right? So 12 pieces, right? So you cut it into the 12 and then you take a few from the middle or however you want to do it. So you take things in chunks. That's what slicing means. Okay. So in indexing, we were just getting one. In slicing, we were getting several things. Got it? This is where I was saying, this is where you want to do 2 for loops. If I say, give me like the bottom half of this array, how do you solve that? 2 for loops, right? You're going to iterate, and if I greater than something and j greater than something, then I start printing it. You would think that way, because that's like the sequential programming that you've learned all these years, but that's too slow. That's the problem. It's too inefficient. Your code would just take weeks to train like that. That's not a solution. And so instead, we want to take advantage of something like slicing in Numpy. Make sense? All right, so let's see this with an example. I'm going to do x equal np dot a range. And I'm going to say this is 15, or print x. All right, so you see I have this array. So now give me the first 4 elements of this NumPy vector. This would be a NumPy vector. So give me the first 4 elements of this. So again, this is where I was saying you did for I in range, right? And then what? What else? Len. You see that? Len of x, right? And then you would say something like, okay, I'm going to print, but we're not going to do it though. Instead, we take advantage of just NumPy and how NumPy works. So I'll give you one example, and I think if I do this one, you'll be able to figure out the other ones. I want the first 4 elements, so I'm going to take, oh, this should be x. And I do this similar to indexing, but when I want ranges, I'm going to use the colon. Okay, so it means beginning and end. So here I want from beginning on, I want 4 elements. I want 4 elements. So we can have issues like off by 1 error. So it's best to always like check how you did it. Okay, so how do I get, if this means range, what are the indices here? The first 4 elements, 0, 1, 2, and 3. 0 here and 3 on the other side. Okay, let's try that. Almost, but there's the off by 1 issue, right? So then 4. See that? And there you go. This is slicing. And this is something that we will use quite a bit. Okay. Now another thing with slicing is sometimes you know that it's always from the beginning until a certain value. So in that case, you don't even have to include the 0. It'll just assume it starts at the beginning. So this should give us the same thing. You can see that. So you don't have to specify. Any questions? All right, so now let's just, make this fun. Let's do a few, you guys tell me, like, what are the indices? So let's do all the values after 3. All the values after 3. Slice from here, all the values after 3. So that would be 4, 5, 6, all the way to 14. Yeah. All the values after 3.
416.
4, 16.
4, -4.
Okay, right. 416. All the values after 3. So that's 4. Okay, good. Also, Mark says -1. You're missing one, Mark. Huh? Yeah. Leave it blank. Yeah. Leave it blank. There you go. See that? Perfect. Instead of doing all those for loops and imagine all that code, how many lines of code that would have been, you just do something like this. This is going to save you a lot of coding space. We will implement KNN a couple of weeks from now, probably in pure NumPy. And it'll be a nice machine learning algorithm. It'll do machine learning. Okay, so, and we will use these kinds of techniques basically. Got it? All right, let's do another one. Another example here. Give me all the even indices. All the even indices. Not even values, but even indices. So that implies step size, right? Something that we did before. So when you want to give a step size, you have the range and then the step size. Okay, so now I need you guys to give me some kind of values for the range and then step size. I want all even indices. What do you think? Yeah. 0 here, right? And then 14, 2. Okay, let's try it. So that gives me 0. Are these even? Yeah, 0, 1, 2, right? So 0, 2, 4. It's missing 1, right? So probably, what if you do this? Yeah, gives me the last one. Got it? Now, let's do this one. Give me all uneven indices. Uneven indices, right? So now it should be the 1, the 3, and so on, right? What do you think? Now, keep in mind also, another thing about the 2 for loops, if it was a big matrix, it would take a long time to process. This is optimized for really large things also. So there's that additional. All right, so uneven indices. How do we do it? Huh? Replace 2 with 1. Okay, that's the step size. So let's see what happens. It gave me all of them. But you're on the right path there. So yeah. instead of 0, 1 here. Okay, okay. And that's it. So you're just shifting it, right? So you're shifting the step. So you're telling it to, so yeah, good. So did it work? So it should be 1, 3, 13. Yeah, it's all of, yeah, great. Got it? Any questions? Yeah, so these are, you know, especially slicing is really important. So it's one thing. This has a lot of the examples, so just practice this a lot. You know, put it in your like cheat sheet on your GitHub, something like that. But yeah, good. So that's one example. All right, let's try another one. Give me all the values, but in reverse. All the values in reverse. X. All the values, but in reverse. So we want the step size to be in reverse. So this is a tricky one, but -1, as it turns out. All the values have now been reversed. Questions? Right, great. So now we're going to move on to slicing, but of matrices. So that was slicing of vectors, one-dimensional array. I can always sometimes call it a one-dimensional tensor. Now we're going to do a two-dimensional tensor, which is also a matrix, you know, that kind of thing. All right, so let's create a new matrix. So I'm going to say np.array like that. And then I like to do like when you guys learn jQuery, I like using this approach. So I'm going to do that. Okay, so 1, 2, 3, 4. Actually, I think we had done this matrix. I'm just going to copy it actually. Okay. All right, so there we go. We have 3 by 4. Yeah, 3 by 4. Okay. Let's run this one. Let's print A. There we go. 3 by 4. Now we're gonna also slice out of here. So what do we want? Give me this. I'll draw it out. Give me just these 4 here. Extract from that just that portion. Okay, so A. Slice. Because this has 2 dimensions, we need to have, before we only had 1 dimension, right? Now we need to have a comma indicating for 1 dimension and the other dimension. And we're still using the colon. So how would you give me just these 4?
What's the question?
Slicing this matrix, we want to slice out of this matrix just these values 1, 2, 5, 6.
1,
5, 6.
Yeah, well, okay.
So
you
that
just need the first 2 arrays, the first 2 elements of this first array.
Okay, so what is the first one here?
What is your from 0? So these are 2. You're slicing from 2 to 2. You need to start from 0.
Okay, maybe. So what's the
colon?
Colon 3?
I have to practice it.
No, right. That's fine. Yeah. And what's the other one? Colon 3. Okay. Yeah.
Come to the colon 2.
Colon 2. Okay.
Because you're starting from 0.
All right.
Exclusive.
Okay. All right. So do you guys see that? All right. So did it work? It worked. And that's the great thing about this. You can just run it and then don't be so stressed. All right. So yeah. So great. So you can slice this out of there. Let's try something else. how do we slice? Give me the bottom. Like this one. 7, 8, 11, 12. How do you do that? This is going to be there, right? But how do we get these 4? I don't know. Oh yeah, I mean, -2. You want to go with that? Okay. Any questions, guys? As I said, do I expect you to memorize this? No. This stuff you don't have to memorize. Just have an intuition of how it works. Keep your cheat sheet. I'm not really going to ask you like, I mean, I will give you 3 problems where you have to do these, but that's just for practice. But in general, the algorithms, what's more important is I will use these things in the algorithms and I want you to know what's going on. It's all about understanding. You know what I mean? Like the algorithms is not like you have to discover them every time. You understand them once and then you just tweak them. But they make a lot of use of things like this to achieve efficiencies, okay? And so what's important is that you understand what this is doing so that you understand the algorithm itself, okay? Otherwise, you're going to be like, you're going to see strange things like this and it's going to affect your understanding of it. Got it? All right. Okay, so we did that. See what else. Let's do shifting. So this is an interesting one. I've done this as a homework problem in the past. I won't do it this year, but we're going to shift a sequence of numbers. Okay. So let's create a vector first. This is actually, you might think this is not important, but this is actually really important for transformers. Transformers do this. So let's do x equal np dot a range 15. Okay. And we're going to print that x. Okay, so we have a sequence of numbers 0 through 14. And we want to basically shift it to the right. I mean, there's a couple of, I mean, this is just an example really of slicing, but that's not exactly like a very sophisticated shifting. Okay. So here, let's see what would happen. So we have x, and actually, let me try with print. It's better. Yeah. All right. So let's do that one, and then I'm gonna do another print of x, and then I want to shift it. So start at 1. Yeah, there it is. So it's shifted, right? So that's what I mean by it. We're just doing that. Now you could think of adding the 0 over here, but that would be more complex. Right. What else can we do? Give me now. Wait, this is a good exercise. Let's do this one. I'm gonna create the matrix again. And then, all right, there it is. So now I want you to slice out of this matrix the second column. You already know? Okay. So so you guys understand, right? I want 2, 6, and 10. Slice it out of there. Okay. So Henry.
So you'll need, so. I just want the second.
Well, for now, the second column, then we can do the second row.
Like manually or like one slice? I don't know if you can do it in one slice.
You can do it in one slice. That's the whole point of this.
Probably, okay, so you're doing.
You know, give you some help, right? So it's a matrix, so you have a comma.
Same thing.
This is still there, right?
So like, try the right side.
Hmm?
I guess try the right side.
So, okay, so this means all rows, and this means, or sorry, this means rows, this means columns,
Yeah,
right?
try the right side.
So you can combine slicing and indexing also. So this might make more sense if this is an index, right? What would be the index? So, because this is column and I want this, so what index is it for this column? 1, yes, very good. And then, okay. And then if now I have column 1, right, that second column, then now I just have to worry about the rows. So which rows do I want? All of them, right? So intuitively, how could you write that in here?
I guess like from 0 negative.
Or just a colon, which goes from beginning to end, correct? So all rows in column 1. 2, 6, 10. Got it? All right, now let's do what you said. Let's do the huh? Sorry? Is this what?
Do you need this for matrix?
Do I need this for a matrix multiplication? I may need to extract if you don't even worry about that, think of actually X and Y. If I had all my data in here, right? Let's think of this. I read all my data. I have 3 samples and I have 4 columns. Let's say that the first 3 are the features and the last column is the labels. This is a very common thing. Data is usually stored like this. The X and the Y are in one CSV or something. So I want you to give me the X and the Y. I like this exercise actually. So, okay.
Sorry.
No, but this is actually, you'll do this all the time. This is what slicing is for. Give me X and give me Y. And I just explained, right? There's 3 samples in there. There's 3 features, the first, and then the last one is the labels. So slice the X and the Y from this data. How do you do it? So it would be A, right? And then also here, A, and then what? Colon here, correct? Do you want all the rows? Yeah. Do you want all the rows for the Y? Yes, very good. Then we got the comma. Okay, so the easier one is probably the Y, right? We just want the last column. 4, 8, and 12 here are the labels. So what is the index there? 3, very good. And then for this one, we need the features, which would be this column, and this column, correct? So how do you do that? That's a range, correct? So colon, we want it from the beginning. We just don't want the last one. exclude the last column. So what would that be? What would it be? 3? Okay. All right, so now let's run it. Let's see if it works. Okay, so X is 1, 2, 3, 5, 6, 7, 9, 10, 11. That's our X matrix, right? We just sliced the X data. Okay, and then the Y is 4, 8, 12, and there it is, 4, 8, 12. And this is actually, you'll be doing this all the time, that we're gonna follow the standard approach of we have a CSV file, we're gonna read it possibly with pandas or with Numpy. We're gonna create a matrix such as this one, and then usually the labels will be at the last column, not necessarily, sometimes they could be the first one. But in general, we'll slice one of those columns to be the Y, and we'll slice the rest to be the X. They're perfectly aligned, you have nothing to worry about. And imagine if you were doing with for loops. And you just get one little error in there, they're not aligned, and it's just garbage in, garbage out. So in this case, you know, this is guaranteed. Any questions, guys? So this is a perfect example of why slicing is really important. We'll be doing this, you know, several times, because as I said, usually people give you the data together, but in machine learning, you always separate the X and the Y, which is what you saw in the first set of problems. All right, so you guys gave me the column, okay? Let's do the row now. Give me one of the rows. Give me the middle row. So this one, 5, 6, 7, 8. Middle row. Give me the middle row. This is what you had suggested. So I want you to extract that one from the matrix. Slice it out.
3.5 slices.
Hmm?
Could you just do, what's your called A?
Was it what?
Could you just do A that's without any slicing? It's called 1.
Okay, okay. Yeah, that is a good point.
I mean, what will actually probably be colon comma 1, right?
No, that works. That works. So you're right that you're onto something there. That would work because it's like the first iteration of the object.
Yeah.
So it's like, so that works in NumPy. You can also do the other one though. You can also do this, right? And that would also. So it's just, you know, these are tricks. And intuitively, somebody thought of this and they made it work. Question? Anyone?
Person invented the -1 function.
I mean, when TensorFlow 1 came out, it was just like it had all these strange things, and then TensorFlow 2 came out, and it was even stranger. These things are developed by software engineers at some company, okay? So they make assumptions, but NumPy is like the nicest, actually. And as I said, I'm not kidding about this. TensorFlow and PyTorch have been getting more and more like NumPy. That definitely today is much better than it was even 4 years ago. Okay. Questions, guys? All right, so let's see if I'm finished with slicing here. Usually I like to cover up until slicing, and then I let you guys try the rest. So remember, go through all the exercises because I'm not going through all of them. I'm only emphasizing the more important ones. This one is, I want to do this example. Reshaping is really important, okay? Reshaping is a pretty essential thing. So let's do that. So this is going to be, we only have like 10 minutes, so we'll probably finish with this. Reshape is, initially we will learn, we will work with images a bit, right? So, MNIST and Sci-Far 10. And we need to manipulate. An image is a grid that is 2 by 2, right? But the simplest way of using an image in a neural net is to stretch it, convert the matrix into a vector, or some people call this spaghettify, and I like that term. So it's just like pull it into a vector like that, right? And we have this function called reshape that's really nice. So let's imagine we have a vector A equals np dot a range 1, 10, right? So that's your vector. So I'm going to print it out. A. There it is. Now I'm going to reshape it to be a matrix, okay? Now you have to get the dimensions just right. You can't, it's not like intelligent. NumPy has limits, right? So it's not going to figure things out for you sometimes. All right, so let's do B equal A dot, and then there should be a function called reshape. This has several names, like PyTorch uses something called view, and I don't know what TensorFlow is using these days, but everyone has specific ways of doing things. All right, so this reshape then, you need to say that, so this should have 9 values. That's really important, okay? So then I do 3, 3. I'm going to reshape it into a 3 by 3 matrix. And that's going to be B. There you go. You see that? And usually we'll do the reverse of this because we'll have an image that is 28 by 28. And what do we want to do? We want to spaghettify it into a vector that is 780. Do you guys see that? That may be the homework problem. So that kind of sounds like a good one. All right, so you might get the reverse of this. I may give you the image and I may ask you to spaghettify. As I said, in general, I try to do examples that eventually will be part of the pipeline. Okay, any questions on reshaping? Pretty easy, right? Okay, so let's see. We have about a few minutes. Let's see if I can do one more. Well, I do want to do this. Yeah, let's do this one. So V, this will be the last. This is something that we have to do sometimes. It's difficult to explain why. Here, it does tie into the math a little bit. There are certain rules in linear algebra when you take a matrix and multiply it times a vector, like the dimensions have to be correct. And also, sometimes you have a vector, right? When you multiply it times a matrix, it needs to be a column vector, not a row vector, if that makes sense. It just has to be that way. All right. So like it's the same values, but they can't be like this, 2, 5, 6. They have to be like this, 2, 5, 6. It's just how it works. Okay. It's the rules of the math operation. And so what's important here is that we just need to be able to make a vector, a row vector into a column vector. Okay, play with that. There's a couple of ways of doing that. So that's the example I want to do in the last 5 minutes. So I'm going to create a vector np.array. Okay. I'm going to put 1, 2, 3, 4, 5. Okay. So I'm going to print this as V. Okay, and I'm gonna print the shape, v dot shape. Okay, 5, 1. Okay, notice, it's like this, right? So now there is a thing in NumPy that allows you to create dimensions. So we can do v1, or v, sorry, v comma np dot new axis. New axis, okay? And then like that. There's a couple variations of this. You see that? And so if I assign this to, well, if I print v now, one by 5, right? So I need to invert it then. You see that? So what if I do okay, 5 by 1? Well, it prints the same, but what matters is that this has changed. Do you guys understand? You guys understand? So let me do print here. Yeah, so it doesn't show it as a column vector, but it does change the shape of the vector, and that's really what matters, because when you do a multiplication, it checks the shapes, right? So really what we see here does not matter. At the end of the day, it's just a buffer in memory in C, right? So to be very efficient. But we were able to change this, remember. Okay, and I'll just take it back to was. See, 1 is 5, comma 1, 1 is 1, comma 5. The first one is a column vector because it's 1, 2, 3, 4, 5, and 1. And the other one is 1 by 5, so it's 1 row and 5 columns. So we are effectively able to change the shape of that vector. And sometimes there are certain operations where it has to have one shape or the other. Initially, because this came from a list, it's like confused about things, right? And so we get this 5 comma. But eventually we use this little operation to make it into more specific shape that will work with the. Now, is this something that, you would need to figure out? No, but when we encounter it, we want to know why it happened, right? And that's why I'm saying. So whenever you see these, like in summary, if you see new axis or something like that, it's because of this. We need to create this additional shape for some operation that we're trying to do. And again, this just, once we do these things, once we use these things effectively, we're able to write very efficient code, okay, with few lines. Also, like your programs, by having these little operations, it's shorter in terms of the code, but it runs really well. Got it? Does this make sense? All right, so anyway, don't worry about this new axis thing. We'll see it again. And like I said, it's just to reshape things. We do a lot of reshaping in machine, right? So there's a lot of that going on. But definitely, slicing is really important. And it's the topic that we covered today. We went as far as new axis, reshape. So you guys should continue. I think the next topic is concatenate. So I leave that to you guys. On Tuesday, I may come back to some of these. If I think they're important, like I said, the most difficult one is broadcasting. Take a stab at it, see if you understand it, but we'll come back to that later. It's a very powerful technique, but it can be very abstract. All right, so for now, I haven't, oh, sorry, we have class on Thursday, right? So start going through these. All right, start going through these. On Thursday, then I may do some of these continue. Right? I haven't assigned a homework yet, but just keep, I showed you the links. I strongly suggest you go through all the problems, do them, understand them. If you have questions, ask. You don't have to do this as homework, but instead I will give you a set of 3 to 5 problems for you to solve. But we'll talk about that on Thursday. Got it? Are there any questions? All right, yes, please. Which one? Oh, the whole Anaconda one? Yeah, sure. All right, so that's it for today. Oh, to close this? Yeah, that's a good point. Let me show you how to do that. So actually, that's a good one, right? So make sure you save, right? Make sure you save. So I've saved, then close this one. Then you end up here, go to running, shut down. I like to shut down the programs. So shut down. So they're all shut down now. Then close. Then you go to the prompt here and you can just kill it. So Control C, X, C. Either Control C or Control X or Control C, it will kill it. And then Conda deactivate. I mean, you could just like hit X on everything and you're probably okay, but if you want the proper methodology, that's it. All right. Yeah, and that's it. And then I'll show you the other. All right, guys. See you Thursday. Yeah. Yes, please.
I didn't manage to open the desktop folder. Doesn't matter really where I'm saving this.
It matters because you want to find it later.
Okay.
Do you know where they are?
I actually didn't read the file.
Yeah, so that's the only thing. You might lose them. That's why I always save everything on the desktop, but I did not today. I forgot. Okay, so you wanted to see the installation of which one?
Yes, because I know I got Conda installed, but I didn't see what the other words were after.
Okay, so once you have base here, you want to do Conda create that one. And that's going to create the environment that you want.
Okay.
Give it whatever name you want. I usually by convention put in the version of Python. And then I just called it ITS 365. So Conda create -- name Py37. This is in my repo in the Unix and Linux commands. It's there. And so Conda create -- name and put the version of Python.
Okay.
Once you do this, it's created. So then you can do Conda environment list, which is gonna give you the list of environments that you have in there.
Okay.
So you can see it's there, right? 365. And then to initialize it, well, if you want to install something here, you can do so by pip install torch or whatever it is.
Okay.
And then to start it, Conda activate your environment.
And so it's on the that's all in the GitHub?
The commands are
Okay.
there's not a tutorial. It's just each command is on the Unix and Linux.
And then there was also pip install Jupyter, right? Or
Pip install Jupyter is the other one we did. Guys, watch the video.
Okay.
yeah.
What are we doing? Yeah, I will post this video later today.
Okay.
Just watch it.
I know. No,